Hello viewer, welcome back to the lecture series on material science and engineering. Today we will discuss about the materials for data storage and display devices. This is the very basic scheme of the recording system, recording head and the data storage tape. The coil is placed in a magnetic core. That magnetic core has an air gap. The gap of a recording head is shown here, and that return yoke core, very small inside, is passing over the tape. So the fringing field is passing through the tape, and the fringing field is used for magnetizing the tape. This is the highly simplified scheme. So there is basically two poles are produced at the air gap, and the flux lines are passing through the tape, the recording medium. As because this is the magnetic type of recording system, so magnetism is produced there with the help of the signal. And here also very small hysteresis loop is being produced. It is a similar hysteresis loop. Is the magnetic induction versus the magnetizing force. And the point B is the retentivity and C is the coercivity. Essential properties of recording and reading head. The first point is the efficiency. One needs material with high permeability. That is an essential criteria. Low hysteresis loss. So is the low coercivity. AC should be low. Low eddy current loss. That is the low permeability. And thin lamination is essential, and high resistivity. And magnetostriction coefficient. So these are the essential physical parameters for a recording and reading head. Easy to machine also should be a criteria, and form different shapes. Good durability against mechanical wear, and reasonably high hardness. So this is the very basic requirement for getting sufficient efficiency and much less loss. This is a scheme. Again, the tape and the head scheme, which is still micro miniaturized. So here, this is the thin film head, and yellow one is the insulating material. The right hand side figure, it is showing the outside white region is the core. So there is this yellow part, there is the gap of the core. So yellow is the insulation, and this white thing is the core of the magnetic material. The coil is made out of the thin film with the non-magnetic thin film of the metal, and the whole thing is put on a substrate. The blue one is the pictorial representation of the tape. This is highly simplified scheme, but it is scheme of the micro miniaturized, very small, this magnetic tape head. So as we have mentioned, here in the head, this magnetic material is used. What are the magnetic material usually preferred and used? Iron, nickel-based alloy, high permeability, electrical resistivity is higher also, and superalloy, molybdenum in the iron nickel base, mu metal, copper chromium in iron nickel. This is the iron nickel based alloys are very frequently used, and iron aluminum based alloy, moderate permeability and high saturation induction. Iron nickel is the high permeability, here it is moderate permeability and high saturation induction. Alphenol is a very specific iron aluminum compound, and sand dust is iron, aluminum and silicon material. It is a composite compound. The third material we should mention is the ferrite. Ferrite are magnetic ceramics which play an important role in the magnetic heads. Generally, they are sintered materials. Ferrites are sintered materials. There are two types of materials such as nickel zinc and manganese zinc ferrites, and have very high resistivity, 4 to 9 order higher than the permalloy, and considerable magnetic properties. Because these magnetic particles are made into granules, and then if the binder is put into that, put into very high temperature under pressure, is the sintering process. These are formed as molybdenum, iron, oxygen, where molybdenum is bivalent metal oxide such as manganese oxide or zinc oxide with the iron oxide powder. That is another composition of the ferrite. These materials also very hard, elongating head life during head-medium contact, because there will be loss due to the contact, there will be the frictional force, so there will be some wear and tear of the head. This is a very novel material, it's the metallic glasses. Metallic glasses are iron-based alloy containing 15 to 20% of silicon boron carbon, offering substantial reduction in coal losses. The basic advantage is the coal loss is very much minimized. From molten state, the alloy is cooled down at extremely faster rate, that is about 10 to the power 4 degree centigrade per second is the cooling rate. During cooling, the mass solidifies to a ribbon-shaped metallic glass without crystallization. Due to the large concentration of impurity atoms, the electrical resistivity is higher than that of iron 4% silicon alloy. This reduces the eddy current losses. The absence of grain boundaries in the glassy matrix reduces hysteresis loss. So the eddy current loss is minimized, hysteresis loss, that is the core loss also is minimized. The total core losses is reduced to 30 to 10% of that of the iron silicon alloy, causing a large cost reduction. Random magnetic anisotropy of made glass help to obtain lowest coercivity, because this magnetic anisotropy is very much random in the made glass. And moderate saturation magnetization. Also, made glass have significantly high permeability and moderate resistivity. So the eddy current loss is minimized and permeability is very high. Saturation magnetization is moderate and coercivity is low. The primary drawback of these metallic core materials are frequency limitation, and dimension inaccuracy and mechanical softness. So it is very difficult to machine out. Made glass is used in phonograph cartridge, audio and computer tape heads, etc. There is the frequency limitation. Here is a table showing the magnetic properties of various types of core materials. Several parameters are shown here. Mu1 is the relative permittivity is so high. And the composition right hand side is the composition. Then is the critical temperature also given here. The materials are tough perm, permalloy, made glass, sand dust, manganese zinc ferrite, nickel zinc ferrite, nickel iron, and iron, rubidium, gallium, silicon. Is a complex mixture. Out of all these, tough palm have the mu1 very high, 40,000. And made glass 20,000, permalloy also 20,000 is the mu. As a specific choice, specific material will be used. This figure shows the magnetic tape scheme. Thin particulate coating 5 to 15 micrometer is embedded on the flexible polymer backing material, that is the polyester plate backing tape. So it is 25 to 50 micrometer in thickness. A magnetic tape is typically a magnetic coating on a flexible polymer sheet in the form of the tape. magnetic data disk. That initially there was the magnetic metal tape, then the polymer tape came into picture with the magnetic material coated polymer tape. Then it has come up the magnetic disk, magnetic data disk. This is still being used. Magnetic data disk has several tracks and head is fixed at a point, and when this disk is rotating, that time head also following the tracks, and radial movement is given to the head, to the motion of suspension of the head. Disk rotates in the anti-clockwise sense. What is the sort of construction? Let us see that. Construction is something like this. There will be a substrate. Over that there will be addition layer, under layer, recording layer, and comma layer. This is a scheme. Another scheme is substrate, addition layer, soft magnetic under layer, intermediate layer, and recording layer, comma layer. Depending upon the requirement of several enhancement of several properties, these two are used. Schematic view is shown here, the top section and cross-sectional view of a thin film media suitable for longitudinal and perpendicular recording. The thin film disk require an addition layer to make enough stick on the substrate for a long life. So the adhesive layer is given, and this life is approximately 10 years duration. In case of perpendicular magnetic recording, the double layer media where the recording layer is deposited on the top of soft magnetic underlayer with an appropriate intermediate layer is suitable for recording purposes. Hence, the soft magnetic underlayer made of cobalt, tantalum and zirconium, cobalt, niobium, zirconium, iron, tantalum, nitride, iron, tantalum carbide, iron, aluminum, silicon, and iron, cobalt, nickel, single layer film, synthetic, antiferromagnetic, hard magnet biased soft underlayer, and laminated type soft underlayers were used for utilizing the single pole head with enhanced magnetic field for writing the recording layer. The soft magnetic underlayer is not mandatory for the case of longitudinal recording. Ring heads are used for writing. This is the information storing or retrieved from a magnetic disk is the scheme by use of an electromagnetic head. So the electromagnet is essential for all the heads. A current in the head magnetizes domains in the disk during storage. So there are several domains. Magnetized region is domain. The domain in the disk induce a current in the head during retrieval. During reading, it recovers the signal, the induced current. This is another scheme. This is the very basic magnetic storage total schematic. The top one is the recording medium and bottom circular one is the recording head. Head can apply magnetic field, align domain, magnetize the medium, detect a change in the magnetization of the medium. As usual, there is a coil. So the signal is induced in that. And this coil can be used both for reading and writing purpose. For reading, the signal is amplified in the amplifier, and for writing, the signal is delivered to the coil. This is a very basic scheme, basic but fundamental scheme. And the recording medium is particulate tape floppy, needle shaped. This iron oxide granules, magnetization of the medium along x-axis. So the magnetization direction is fixed. Thin film hard drive, cobalt platinum chromium or cobalt chromium tantalum alloy. Domains are 10 to 30 nanometer. Is very fine. This is very fine domain is there in the film. So this recording medium is very fine and finely controlled thing. As all of us is knowing about the floppy disk was being used previously. A floppy disk, also called a floppy diskette or just disk, is a type of disk storage composed of a disk of thin and flexible magnetic storage medium sealed in a rectangular plastic enclosure lined with fabric that removes dust particles. Floppy disks are read and write by a floppy disk drive FDD. So these are the basic features of the floppy disk. Magneto-optic devices. So far we have discussed about the magneto-electromechanical devices. But here the optical counterpart is introduced in these magneto-optic devices. In computing, an optical disk drive ODD is a disk drive that uses laser light or electromagnetic waves within or near the visible light spectrum as part of the process of reading or writing data to or from optical disks. Some drives can only read from certain disks, but recent drives can both read and record, also called burners or writers. Compact disc, DVD, and Blu-ray disc are common type of optical media which can be read and recorded by such drives. These are called CD, DVD, ROM computer drive. These are usually used in the computer, laptop, and also very portable devices also are being used. So these are the magneto-optic devices. So the optical counterpart is there for the alignment of the recording. Very fine alignment is being carried out by the laser light. Hard disk drive, this is an essential part of the computer, laptop, and desktop computers. We all know this is a very popular one. It is having the power connection, the SATA connector, jumper, read write head that is very finely aligned read write head. Then the actuator for changing the position of the read write head is the actuator arm, actuator axis, and the spindle over which the actually hard disk is mounted, and is the platter. Western Digital and IBM introduces the disk drive with the thin magnetoresistive heads, which stores about 1 GB data. Over last 2 decades, the discovery of GMR heads and spin valve based heads boosted the hard disk industry to fabricate high storage space drives for various applications towards consumer electronics. The capacity of these drives, it has extended up to 1 TB and more nowadays. This is another very very preliminary but very fundamental and still very popular type of ring head and disk. The disk drive parts and their functions are given in the list below. Since the purpose of the hard disk is to store data and retrieve it reliably over a long period, the hard disk medium should be fabricated on a rigid platform to avoid any damage. This platform, along with the deposited film for recording, is called as platter. So in the hard drive, we mentioned about the platter. Here it is. The detail of the schematic of that is given here. The platters are fixed on a spindle which rotates at a speed varying from 1800 revolution per minute to 10,000 revolution per minute. That is the relative velocity between the head and the disk is about 40 meter per second, is very high. The head writes and reads data from the disk. The head is located at the end of the actuator arm, and it is a part of the slider which has flexible connection to the actuator, and it has a profile surface facing the medium that forms an air-bearing surface, allowing the head to hover at a close distance of about 10 to 100 nanometer from the medium. So it is very near, but it is not exactly doing the scratch, or it is not touching mechanically. Also, the actuators provide a mean of moving the head or slider from one track to another and produce motions to retain the head in the center of the track. So in the scheme, it is very much visible. There is a magnet coil yellow and the GMR head, GMR reed head. Then is the horizontal magnetized beads are shown here. Then is the right head. That magnetic flux lines is going through it. The recording medium is shown below it. That is in the form of the domain. CD, DVD, read and write mechanism. Digital information track is fabricated on the disc, rotating disc. Read and write head is moving over it without touching. This is a very composite but very advanced type of recording head. It has the substrate. Over the substrate, there is this digital information track. Then the head contains coils, inductive thin film right head coils, which is already discussed, and the constant current signal voltage is applied to the GMR sensor, and there will be a shield. So this head composed of all three components is the GMR sensor, is the shield, and the right head, which is a thin film, inductive thin film right head. So it is a composite assembly. Just below that there will be the digital information track. The right inductive head and the GMR head sensor have been integrated into a single tiny read write head. This is very advanced type and very much in miniaturized. This is very small. Here is a comparison of several types of storage devices: CD, DVD, HD DVD, and Blu-ray. While a DVD uses 650 nanometer red laser, Blu-ray disc uses 40 nanometer, 405 nanometer blue laser diode. Although the laser is called blue, its color is actually in the violet range. The shorter wavelength can be focused to a smaller area, thus enabling it to read information recorded in bits that are less than half the size of these on a DVD, and can consequently be spaced more closely, resulting in a shorter track pitch. It enables a Blu-ray disc to hold about 5 times the amount of information that can be stored on a DVD. The lasers are gallium nitride laser diodes that produces 405 nanometer light directly, that is without frequency doubling or other nonlinear optical mechanism. Conventional DVD use 650 nanometer red laser and CDs use 780 nanometer near infrared laser. So the laser wavelength is different for different type of recording. 780 nanometer is for the CD, 650 nanometer for DVD, 405 nanometer gallium nitride laser. So these are the 4 different lasers are used. For CD it is 780, for DVD 650 nanometer, and HD DVD 405 nanometer without frequency doubling, and Blu-ray it is 405 nanometer. Comparison of various optical storage media is shown in the figure. Magneto-electronic materials in general, about 3 ferroic phase such as ferromagnetic, magnetic field and BH loop, ferroelectric, electric field and PE loop, ferroelastic stress and AC loop phases are present in it. Multiferroic materials shows more than one ferroic phase combinations. Magnetoelectric materials are multiferroic, showing magnetic field induced polarization and electric field induced magnetization. This coupling between magnetization and polarization exists with the respective electric and magnetic fields. All magnetoelectrics are multiferroics, but all multiferroics are not magnetoelectrics. That is the very basic thing. So here is the classification of multiferroic and magnetoelectric materials. So this ferromagnetic circle and ferroelectric circles are interlacing each other, and again magnetically polarizable. One is interlaced with the electric polarizable. So the common area is the multiferroic. Magnetoelectric and the finest common area is the multiferroic, is the scheme. Is the all the properties are embedded in the multiferroics. The multiferroic materials are either rare earth magnetites or ferrites or transition metal perovskite oxides. The examples are several, many compounds are there. Mostly rare earth materials are used here, elements are used here in conjunction with the oxygen. So those are the oxides mostly. Some non-oxides are also multiferroic, such as barium nickel fluoride and spinel chalcogenides, that is zinc, chromium and selenium compound. So these are very advanced type of materials are used here. Is the magnetoelectronic materials. So this is very frontline type of devices are using all this. Bubble memory, it is so catchy word. What is bubble memory? Bubble memory is a type of non-volatile computer memory that uses a thin film of a magnetic material to hold small magnetized area. So it is basically made out of the thin film of the magnetic material. And these are known as bubbles or domains. Each strong one it has very strong physics foundation. It can store 1 bit of data. The material is arranged to form a series of parallel tracks that the bubbles can move along under the action of an external magnetic field. The bubbles are read by moving them to the edge of the materials where they can be read by a conventional magnetic pickup and then rewritten on the far edge to keep the memory cyclic through the material. So it is cycling through the material. So the one can go from one edge to another edge. In operation, bubble memories are similar to D-aligned memory. D-aligned memory systems. The introduction of dramatically faster semiconductor memory chips pushed bubble into the slow end of the scale. So this is the most latest type of semiconductor memory, and this is dramatically faster and equally dramatic improvement in the hard drive capacity made it uncompetitive in price terms. So these are the most latest memory system. That is the semiconductor memory. Thank you.